Yo, welcome to Physics with Vinay.
So here we have a question in which it looks like a laws of motion problem. It looks like a difficult laws of motion problem. But in such question, I'm going to show you how to convert this into an easy circular motion problem. So first, let's just read the question. A bead of mass m which can slide on a straight horizontal frictionless rod is being pulled with the help of a light inextensible thread of length L. So this is the bead that can slide over the smooth rod and it's being pulled by the string in such a manner that the end P of the thread which is being pulled moves with a constant speed V0 always directed towards or along the thread. So this end P always has a velocity along this thread. Find an expression for the tensile force T in the thread at an instant when the thread makes an angle theta with the rod. Alright, in such questions where you have a particle and connected by an inextensible thread, always go in the frame of one end of the thread, because if I go in the frame of point P, the bead is going to be at a constant distance from point P. That means its motion is going to be circular motion. So what I'm going to do is I'm going to convert this problem which looks like a tough laws of motion problem into a simple circular motion problem by simply going in the frame of the end of the thread. Now because the question is asking tension force, what do I need? See, I'll have a tension force this way and the acceleration of the bead will be to the right. So can I just write T cos theta is ma. So if I can get the acceleration of the bead, I'll get my tension. So that is my aim now, to get the acceleration of the bead. So for that I'm going to go in the frame of point P. So in the frame of point P, this bead is going to perform circular motion. So let's say its velocity is v relative. Now how much will that velocity be? So end P has a velocity of v0. So this should be v0 here. See, I know that in the ground frame, the bead has a velocity v to the right and point P has a velocity v0. They'll both have the same velocity components along the string. That is the constraint equation. So the only velocity component that will remain in the frame of point P would be v sine theta, the component perpendicular to the string, and that will be v relative. Now I want to express it in terms of v0, so I can just use the constraint equation that v cos theta is v0. So v is v0 by cos theta, so this will become v0 tan theta. So v relative is v0 tan theta. Now, can I write the component of acceleration of bead along the string, the normal component in the frame of point P, will be nothing but v relative squared by L. So this is the main equation. In such problems, what we're going to do is we're going to write the component of acceleration along the string, because that will be the centripetal acceleration. In point P frame, bead is performing circular motion. So this will become my centripetal acceleration. Now, I would like to express An in terms of the acceleration of the bead in the ground frame. Now, the question says that the point P has a constant speed always directed along the thread. So therefore, the acceleration of point P along the string will be 0, because there is no change in the velocity component along the string. So any acceleration of point P will be perpendicular to the string. In general, I can write acceleration of bead with respect to P should be equal to acceleration of bead minus acceleration of point P, but I only need the normal component. So the normal component is 0 for the point P. There is no component of acceleration of point P along the string. So the normal component of bead with respect to P will simply be the normal component of bead in the ground frame, which is nothing but A cos theta, component of A along the string. Alright, so that's it. We are going to substitute An here and we're going to substitute V relative here. So what we get is A cos theta should be equal to V0 squared tan squared theta by L, and thus you get acceleration from this equation, and once you get acceleration we get tension. So just substitute acceleration from this equation here and you'll get your tension as v0 squared by L sec square theta tan square theta. So I hope you've understood how we converted this difficult looking laws of motion problem into a straightforward circular motion problem simply by going in the frame of one end of the string. In the 53rd question, a light inextensible straight thread of length L is placed on a frictionless horizontal floor. Block is placed on a floor, is attached to one end of the thread. With how much constant speed V0 is the free end of the thread must be lifted vertically upwards here so that the block leaves the floor when the thread makes an angle of 30 degrees. So at the instant the block leaves the floor, the tension should overcome mg, the vertical component of tension T sine theta should be equal to mg, and of course the horizontal component of tension will provide the acceleration. If I just divide, I'll get acceleration as g cot theta, and theta here is 30 degrees. So at the instant the block gets lifted off, the acceleration is g root 3. Alright, now let me call the top end of the thread point P. So I'm going to go in the frame of point P, because in the frame of point P the block is at a constant distance of L, and therefore that will mean that the block is going to perform circular motion. So in the frame of P, the block is going to perform circular motion, so it will have some v relative perpendicular to the string. Now let's say the block has a velocity v to the right. So in the frame of point P, it will have v to the right and v0 downwards, because point P was going up with v0 in the ground frame. And the resultant of these two would be v relative. So this is angle is theta, so this is also theta. So can I just directly write, see v0 is the y component of, or the vertical component of v relative. So can I just write v relative is v0 by cos theta from this triangle. And now I'm going to write the acceleration of the block along the normal, because that will be the centripetal acceleration. Point P is inertial frame because it's moving with a constant velocity upwards. So the acceleration of the block in point P frame will also be a to the right. So what is component of a along the string? A cos theta. So can I say a cos theta should be equal to v relative square by L. And that's it, because I can substitute a as g root 3. So g root 3, and what is cos theta? Root 3 by 2. And what is v relative? See, v relative was v0 2 by root 3, because you had v0 by cos 30. So v relative squared would be v0 squared 4 by 3 L. So that's it, and you'll get v0 squared, or rather v0, as 6 meter per second. Just substitute g as 10 and substitute L here as 3.2, and you can solve it on your own. So here we see how we convert a difficult looking laws of motion problem into a straightforward circular motion problem simply by going in the frame of one end of the thread.